Hello everybody. Okay, I didn't do a great job at promoting this stream, but can you hear? Let me make sure. Is this better? This is probably better audio. I'm trying to check and double checking here. Let's see if the audio is good. I'm gonna wait till somebody's watching, see if we have any viewers. I hope the audio is good. Let me make sure here. Okay. That's my output device, my Yeti. Let me see. No. Okay. Okay. I think this is what's gonna work. So if anybody's viewing, just maybe give me a thumbs up if you can hear the audio clearly, because I want to make sure the audio is good. Okay. So let's see. Let me just double check to make sure that my microphone works just fine. Hello. Okay, I think this is good. So what I want to talk about is there's three important things when it comes to PCB design. Now, I'm going to share 3 secrets over the course of 3 videos, and there's going to be a webinar to discuss the secrets in more detail, but I just have to split it up that way to cover all the material. And I have my phone here as a reference. I'm just going to be reading off my script, more or less. And just as bullet points, I put my bullet points here to let you know what's going on. So first of all, there's a problem that I noticed when it comes to PCB design and when people are trying to get, more and more people are trying to get into designing printed circuit boards, which is fine. You viewers on here, thank you for supporting my channel, by the way. I really appreciate all of the views and on all of the feedback that you provide on my YouTube channel, on Facebook, just everywhere. And so what I want to talk about today is the first problem that I see that we have, which is in undergraduate, like when you get your electrical engineering degree and you're an undergraduate or even a graduate student, a lot of times we're not taught how to design our own printed circuit boards, right? And of course, this should be common knowledge, right? This is common knowledge. A lot of times we don't learn PCB design. So where are we supposed to learn it? When are we supposed to learn it? A lot of the PCB designers manage to gain their skills through their experience, okay? And I'm just checking the chat here to make sure my audio is good. Okay, cool. And you learn on the job, right? So the point of what I want to tell you today is you don't have to wait until you get the job to learn PCB design. A lot of you already know this. There are a bunch of YouTube channels out there, YouTube videos that show the process, how to do it in the software. How it's being taught, though, is, hey, and this is how I started off. I started off with the software tool. I don't know where anything is, right? I don't know what to do with the tool, okay? And it becomes frustrating because I don't know what to do with the schematic software. I don't know what to do with the PCB design part because I don't know how to lay out a PCB. And the question is, well, where do I start? So what if the tool is powerful? I don't know where to start. And so starting is a big problem. Now you already have your electronics engineering degree, your ECE degree. Maybe you already did a software engineering degree, but you want to learn PCB design. Maybe you do embeddeds, but you want to know how to design the PCB. The first thing I would say for this big secret number one is that there are resources out there, but there's a certain path or order you want to start learning in order to do PCB design. So I strongly believe in theory then application. Why? Because whenever I start with application and I don't know the theory behind why I'm doing things, everything is just a bunch of rules to memorize. I download cheat sheets and application notes that have like literally like 40 rules of thumb, 50 rules of thumb for PCB layout, rules of thumb for this schematic design, uh, things you need to be mindful of for just reading a schematic properly and picking parts. How do I know how do I pick parts? When do I need to know when to pick parts? What's the design? A lot of it's confusing. So what I want to do in this secret number one is to say there is a particular order I strongly recommend if you're new to this game, or even if you're not new but you don't have all the parts. There's a process and the steps you take. Now, if you have not gone and downloaded my 7 secrets to become a professional hardware engineer, please download it. If you don't know where it is, you can just ask me right in the YouTube comments. You can comment down below, or you can email me at kirsch@hasofu.com. It's in the description of below this video, or will be. Or if you want, in fact, I'll just type it. So it's kirsch@hasofu.com. I'll get to the process real soon because I don't want to waste your time. I don't plan on being here more than about 20 more minutes. So, what is the process that I recommend? You don't have to do it this way. I didn't learn PCB design in this order, but it took me 5 years to get decent, to get okay, to get kind of good, right? But if I did it in this order, I wouldn't be so confused. I wouldn't be lost. I wouldn't be wondering, where are these rules of thumb coming from? Why do I have to remember all this stuff? What's this list I need to remember? So here are the steps I recommend to learn. And it just so happens to be in the 7 secrets PDF. So if you haven't downloaded, download it. It's in the description below and sign up to my list. The first step, let me pull up my phone with my notes here. I already forgot the first step. Okay, cool. The first step is we have resources out there, and the big secret is that we have online resources to learn all of PCB design, so you don't have to learn it on the job. So the first step I recommend is oh right, understanding how a PCB is actually made and fabricated. I post some links in the comments below, but the first thing I think you should know that I mean, this is actually pretty embarrassing to admit. I was milling out printed circuit boards for about a year, and I didn't like on a CNC machine. And whenever students needed to, when I was a teaching assistant, whenever students needed to do solder mask or paste mask and stuff like that, for a year, I didn't know what those were. I didn't know what solder mask was or what paste mask was. I knew what the green stuff on a printed circuit board was, but I didn't know. I was like, well, what's solder mask? So whenever I would have them send off the designs to a fabrication company to fabricate the PCBs because I couldn't mill it out on my CNC machine or our university CNC machine, I couldn't help them. And I didn't understand why the students didn't trust my knowledge about the regular copper layer stuff and PCB design. It's because I didn't know anything. I didn't know shit. Sorry, my excuse my language, right? So it wasn't until I came across some YouTube videos, some books, and some resources that explain the different layers: photoresist, pre-preg, core, laminate, copper layers, copper pores, vias, vertical interconnect accesses, vias, um, and just physically how the PCB is made. I didn't think to learn that first, right? So I'm sure a lot of you are way ahead of the curve than I was, much faster, much more ahead of the curve than I was. And I won't admit how not how recent ago that was, a few years now, but The point is learn how a PCB is physically made, the actual material, and the process that manufacturers go through to stack those layers on top of each other. That's important when you get to PCB layout. And also, if you want to design multi-layer printed circuit boards, high-speed design for Internet of Things, you need to know about core, laminate, and prepreg and thickness. Okay, so that's why this is important. If you want to lay out high-speed PCB, there are equations and impedance matching and stuff like that that depend on the physical properties of the entire PCB, not just the copper traces. Well, I've gotten questions where people don't know what thickness or width to determine that their trace needs to be. It depends on the layers of the PCB, the copper and the non-copper layers. So you want to, and so that's one reason you want to lay out multi-layer PCBs. You need to know how the PCB is made. The second thing is why do you need to learn how the PCB is physically made? You need to learn it because this will make the layout process um, about an order of magnitude easier to understand. Because first of all, a lot of times we don't understand, we don't remember the layout process because we don't understand what we need to lay out. We don't know if we know everything that needs to be laid out, then we'll understand the layout process. Okay. And if we understand something, it's much easier to learn something. Okay. So down the road, when you learn PCB layout, it's not that you can't learn layout if you don't know how a PCB is fabricated. I'm not saying that. I'm saying you can significantly reduce the amount of time you spend learning layout by knowing the layers that go in the PCB layout process. That's all I'm saying. Okay, so start with the PCB layout, and I mean, not the layout. Start with PCB fabrication and understanding how that works, and it will make everything else much easier. Okay, I spent too long on that first point. I'm gonna hurry up. And I'll have some resources for you to go through how the PCB is actually made in the factory, and it's pretty cool. Okay, uh, the second thing is we need to learn how circuit designs are made. Okay, so this may be controversial, or maybe I think it's controversial and it's actually not. I mean, a lot of these things are common sense. If you've been in the PCB design space, you already know a lot of these things. Okay, hopefully. But I've seen people ask whenever they try to get into PCB design, it's like, where do I start? Where do I start? Okay, all right. So first of all, it's very possible, and people do this all the time, decades, where you can do PCB layout and you're good at that, but the engineer doesn't know electronics design as well or at all. I mean, okay, not at all. If you have an electrical engineering degree, you know electronics design. But it's possible for you to not get an electronics degree and understand how to do some nice layout. But how things are becoming nowadays, if you want to design your own board from scratch, if you want to design a board for your job, if you want to do a startup, if you want to understand how the design works, you need to have some understanding well, of how the PCB layout works. You need to have some understanding of how to design the electronic system that goes on the PCB. Why do I say this? Because now that designs are becoming more vertically integrated, meaning you start from the concept to completion, from mind to market. Um, uh, in order to understand it, in my mind, personally, I like to know what type of behavior I'm working with my components. So if I have capacitors on the PCB, I need to know which capacitors are bypass capacitors for my circuit or my chip. Oh, and because in the layout phase later, I need to know whether to place the bypass capacitor. If I know a capacitor is supposed to bypass to minimize ground bounce, then I will know that capacitor C1 needs to be close as hell to to the chip that generates the signal. Time and time again, if you're new to PCB design, And you're not going to know this, okay? You're not going to just know this. People are like, oh yeah, uh, place all your capacitors, your bypass capacitors next to the chip. Obviously, no, it's not obvious. Okay, people ask on Reddit and forums, hey, can you check out my PCB layout? What do you think? And it's like, well, why do you have your bypass capacitor so far from the chip? I'm like, I don't know. I never done this before, and we never got taught this in college. Excuse me, I'm getting sort of soapboxy because it's frustrating. It's frustrating when you don't know. But if you are able to design electronics, first of all, electronic circuits, you can look in reference designs and application notes, and they'll tell you, the experienced engineer in the documents, they'll tell you that you need to place these chips as close as possible. I mean, the capacitors as close as possible to the chips. And they'll give you other guidelines as well about for a switch mode power supply, which part of the circuit you need to avoid during layout, or which how much current is going through a part of a circuit. If you design the circuit, you know how much current is flowing. That's also going to affect your layout. The layout is just a physical implementation of the idea, of the concept. If you don't know what's going on with the idea or the concept, how do you know if your trace is going to accommodate the 2 amperes, the 2 peak ampere that's going to go through your inductor and the traces around your inductor? How do you know that if you don't know how to design the electronic system? How do you know, right? So the second thing, and I'll recap, I took too long. The first point is learn how a PCB is fabricated. The second point um, is understand and refresh. Maybe you need to refresh. Go through your electronics one and your electronics two books, Sedra and Smith. Go through circuits one and circuits two. Right? It's a lot of stuff. You don't have to do all of them, but which circuits do you know? Which circuits do you need to learn? Right? If you want to have a cookbook or a reference for circuits that are useful, that are actually practical, you can check out the Art of Electronics book, and also the actually no, save that for last. A lot of people swear by the Art of Electronics, but personally, save that for last. That's a cookbook after you already know design theory. Okay, before that, look at electronics for practical electronics for inventors. That's a very popular book. You probably already know all these things. I'm just codifying a process for you that I recommend that would have made my life a lot easier. Instead of spending 5 years fumbling through PCB designs, it would have taken me literally, because I've tested this with undergraduate students who know nothing about PCB design. It'll take you down to 3 months to design nice quality, almost professional level boards. 3 months. And that's actually getting the board design finished. 3 months. 0 to 3 months. Okay. So instead of 5 years, like me, I learn a little slow, but when I learn it, I get it. You could squish that all down to 3 months, and you understand the kind of the full spectrum. Anyway, to get a multi-layer PCB, I'm getting pretty passionate about it. So fabrication. The second, electronics design, because that's going to affect your layout, your trace widths, your trace thicknesses, stuff like that. The third point, the third step I would take, and I'll leave links to these recommendations in the description for this video. Okay. The third thing I would say is, now in the guide, the pre PDF, I say learn the PCB layout process. Right. Um, you could learn this first, or you could learn this. You could learn footprints. So why are footprints matter? It's a natural progression from the electric components to go from electric components to the footprints, because you get exposed to how they physically look in real life. So when you build your breadboard and you order your parts, and then you would stick your through-hole parts onto a breadboard, the physical components, and then you would hook them up and wire them together and stuff like that. Same thing, except you would most likely, for multi-layer designs and high-speed designs, you're using surface mount components. Order some parts, see how tiny they are, see how big they are, understand a 0805, 0603. So where do you get that information and knowledge from? The IPC standards. We don't we never hear about IPC in undergrad. Okay, I learned about IPC the hard way when my boards didn't fit my components. That's how I learned about IPC. Okay, when I wasted some of my research professors' money. uh, and then I also learned about the JEDEC or JEDEC. That's what I call it, standards. JEDEC controls is the standards of volunteer standards from expert electrical engineers all around the world, organizations that say, hey, here's a standard size for a package for a part. Here's the standard sizes and packages for different parts that you've designed into your schematic, right? Because if when you have a schematic, it's just pie in the sky stuff. I mean, in theory it works, but practically, how big are these parts? How little are they? And the IPC standards, there are certain standards that are important for knowing general tolerances for your components and how they need to be placed, and IPC standards, just IPC and JEDEC. All right, that's all I got to say about footprints. Once you understand package footprints and get an idea of how large and small these parts are, you need to place them on a board. This is the fourth phase where we go into PCB layout. Now, you might have noticed I didn't mention simulation. A lot of times you don't have the luxury of simulating your concept. I like power electronics because when it comes to power electronics, I have a lot of models I can simulate, but I'm not mentioning simulation here. Um, Although I am a strong advocate of simulation for your concepts. Anyway, we did, let me recap, learn how to fabricate the PCB, how it's physically made. Why is this important? It'll affect your layout understanding down the road. Two, learn ORCAD circuit design because that's what drives circuit schematics, right? Your schematic is the real idea. The PCB layout can be affected by a schematic because so you need to know the currents that go through that in order to lay out your PCB and the track widths. Learn PCB, no, learn footprints. I recommend it. It's not mandatory, but I mean, hey, it makes things a little easier. You don't want to be surprised by parts, footprint parts. IPC standards. Fourth phase, learn PCB layout process. So this is the holy grail, right? This is what everybody wants to learn. This is what everyone wants to know. Here's the thing: if you don't know how a PCB is fabricated, you're gonna have a harder time. It's not impossible, but you're gonna have a harder time uh, following the 100 million rules of thumb to laying out a PCB on which step to take and where to go here and where to go where. And I always get the questions: what are the layers? What are the class? What is class and subclass in ORCAD? What are layers um, in Altium? And it's a legitimate question, but see, the thing is, that's something you would ask if you don't know the layers that actually make the physical board, right? All the software is doing, all the process is doing, is having you design, come up with a design that tells a manufacturer what you want on your custom PCB. If you know all the typical layers that make a custom PCB to make any PCB, you'll then at the layout phase, if you have that knowledge at the layout phase, you'll know what to look for. You'll say, hey, I need silks. I know I need silk screen. I know I need solder mask. I know I need paste mask for my parts. I know I need assembly stuff. You know what you need, so then you know what to look for in any PCB design software, and that's how that works. Now, the PCB layout process, that's something that you do need to learn, and that process, uh, when you learn that process from seasoned engineers, there are books that I strongly recommend, like Coomb's book or a guide to PCB layout. Just look up PCB layout books and go check out some online courses. We have online courses now everywhere on udemy.com. Trying to think of some other websites. Udemy is the big one. And I have some websites as well if you're curious about my websites, Learn or Get Online. A new one will be is hasofu.com. Check it out. It's still under construction. It'll be out next week. Okay, I said a lot. The PCB layout process, and I'm going to be tying this up in 6 minutes. Okay, I'll do my best to finish everything up in 6 minutes, so stay with me. Um, That PCB layout process, as you're learning it and you're learning rules of thumb from like Nine Dots Connects, I highly recommend them. Um, Reference Designer, and some other cool websites. When they're telling you which steps to lay out stuff and rules of thumb, knowing the manufacturing process helps you understand why we do layout the order that we do it. If you don't understand what the board, if you don't know what the board is made of, how are you going to understand or grasp why you're laying out the layers? So you're learning what to do, how to do it. I mean, when to do it, how to do it, but you don't know why you're doing it for each layer. That's how I went through PCB design. I mean, PCB layout. I didn't know why, because silly me, I still didn't take the time to figure out what is actually in a PCB. To me, it was I didn't even think about it. And then when I thought about it, finally, I was like, ah, that sounds boring. I'd fall asleep. But it helps. It's not mandatory, but it helps you understand why you have 125,000 rules of thumb. I mean, it's an exaggeration by a couple orders of magnitude, but it feels that way. Um, but it'll just make it easier to digest those layout steps. Now, let me see. What else do I have for layout? Um, right. An important thing for layout, once you're laying out the PCB, there's a question. Will the PCB work? There are two answers. There are two ways to answer that question. The first way or first secret is, which is in the PDF, design for manufacture. What is designed for manufacturing or DFM? The board needs to be physically made. There are these machines in the fabrication process that could only, oh, hello. Oh, I can. Hey, Aditya, can you hear me? Okay. I'm just gonna type it in the chat. I hope everyone can hear me, because if you can't hear me, that would be unfortunate. Okay, great, great. Okay, and the audio is decent, I hope. Because I don't know which microphone is working. I don't know if it's this mic, or if it's this mic, or if it's this mic. Well, hey, it's my first time doing YouTube live, so that's how it is. Um, well, that's a poor excuse. Actually, I should have practiced this beforehand. But anyway, but yeah, nice to meet you. Thank you, Aditya, for coming in. Thank you for people who are viewing. Oh, awesome. Okay, great, great, great. That's good to know. All right. Just as a recap, because I see a fifth viewer came in, um, we understand how the PCB is fabricated. Okay, I'm going to be going over the 30 minute, but let's see if I can make it 35 minutes. I don't like webinars and stuff to be long. I don't like to waste a lot of time. Um, PCB, how it's fabricated, that's step one. If you want to lay out multi-layer high-speed PCBs, understand how they're fabricated. Why? Because that'll help you with the layout process. Okay. Step two, learn circuit design, because that's what drives circuit schematics. It's not mandatory to learn circuit design. I'm just trying to make it easier to become a professional PCB layout expert in more like 3 months, maybe 6 months, not 5 years. You don't need to spend 5 years to do that. You can spend 3 to 6 months if you follow these steps. So step one, PCB fabrication. Step two, circuit design. Not mandatory, but highly recommended. Learn PCB layout process. Footprints. Step four, PCB layout process. Okay, and I explained the reasons why that's important. Step five, design for manufacturing. Why is this important? It's important because the PCB needs to be made properly. People ask, how do you rotate the parts? How far do you put them from each other? Here's a question. Do you know if you should put that small capacitor right behind or right to the left of the big capacitor? Is that a problem? Actually, it is a problem depending on the wave soldering process. See, you would know this because you know how if you know how a PCB is fabricated, how a PCB is assembled. You'll know it because of the way you know about the wave soldering process. You know that there would be a faster cooling behind a bigger part. So you don't want to put your small capacitor behind a big part. And you'll know about tombstoning. So you know that certain spacing is important to keep from your certain components. That's designed for manufacturing. You're literally designing your parts and rotating them so that they're easier to manufacture in that wave sorter process and to add those components automatically, assemble those components. But it's just not component assembly. It is actually the traces. If you I've seen PCBs where there was 4 mil traces. Here's the embarrassing thing. When I was doing a CNC machine to build students' PCBs, I didn't see a problem with a 4 mil trace because I didn't know any better. I say, oh, our CNC machine could do it. And then it would mill out the 4 mil trace. A mil is a thousandth of an inch. I don't know how much it is in millimeters, but that's a thousandth of an inch. So 4 thousandths of an inch trace. I'm like, oh yeah, that's fine. Everybody's like, oh, it's fine. Yeah, 2 mil trays, 4 mil trays. I mill it on a CNC machine. I can't even see the trace. I literally couldn't see it. And then as soon as you try to solder something to the copper pad at the end, it gets lifted up. The whole trace get actually even when you would score off the board on the top copper, the trace would get pulled up. Well, done. Yeah, good luck working that circuit board. But they didn't realize because they didn't do the design. They didn't realize that they could go and should go 12 mils on the trace, not 5 mils, like what the default software tells them, because we didn't know any better. This was Allegro we were using. The default trace width was 5 thousandths of an inch. Probably still is. Nobody knew that we should probably do 12 mils. We should probably do 20 mils to carry more current. Our hardware design engineer professional, I won't name his name because I haven't asked his permission, but he helped guide us. 20-year veteran guide us to say use this thickness of traces. But anyway, no, I'm finished with the long story. You're trying to get the good stuff, right? So design for manufacturing is important. If you don't know about design for manufacturing or DFM, that is something you can learn in the IPC standard again. Now the IPC standard, you need to pay for it for the latest standards, but you can find the first IPC standard, I think from 2008, 2002 for free. I'm not going to say where, but you can find it for free. Anyway, IPC. And if you have $160 lying around, you can buy the latest IPC standard, IPC 7351B for footprints and IPC 2221 for PCB layout in general. That'll give you pretty much all the answers you need to do PCB layout. Okay. Hurrying up. Why is this so important? Well, you need to lay out the PCB, but there's another reason down the road. If you know the PCB layout process, then you could learn any PCB design software much faster. Okay, I was trying to learn Allegro for PCB design and PCB layout at the same time. This is probably why it took me 5 years because I started from the end and I worked my way backwards eventually. Okay, design for manufacturing. That's important because if you can't manufacture the PC, because if the PCB works in theory but it can't be manufactured, it doesn't matter if you have the greatest design in the world. Okay, um, so trace width, and this is important because you need to know the limits of your manufacturer. So when people ask, "Hey, what manufacturer should I use? What board house should I use?" and people give recommendations, you need to be able to go into their website, see what features they provide, how thin and how thick they can make their traces, and what tolerances they can deal with. So you can go back to your design and design accordingly for manufacturer. So if you have a 1 mil grid, or no, a 0.01 thousandth of literally a 100th of 1,000th of an inch inch grid when designing your PCB, and you have 27.12258 degrees rotated on your chip, the manufacturer is not going to make that PCB, okay? Because their machines could only move so small a distance. So you need to know design for manufacturing, IPC standards. If you want more information about any of this, email me, kirsch@hasofu.com. All right, signal and power integrity. This is the holy grail, okay? Now that you know PCB layout and you know design for manufacturing, you can guarantee that your board can physically be made and automatically assembled. That's great. But Are you going to have crosstalk on your traces? Okay. Are the signals going to come through nicely? Can you lay out a high-speed PCB? Unless you know this 6 point, which is signal integrity, you're not going to be laying out no multi-layer high-speed PCBs that actually work. So this is the answer to the question, will it work? No, it's not going to if you don't know signal integrity. How do I learn signal integrity? What the heck? What is signal integrity? And also power integrity. Those are two things. They have overlap. They're interrelated. They all come from electromagnetic theory and phenomena. So you need to dust off that EMAG book. You need to dust off that physics book. This is this is where it comes in handy. Now, if you've been designing antennas, like an antenna design course, then that comes in handy. You get a refresher on that. But in my opinion, this is where it all comes together. In fact, PCB design, in my opinion, is the one practical way that's easily accessible to every electronics and electrical engineer. Um, that just brings it all together. Practical experience, entrepreneurship, if you want to, hobby stuff, art, design, um, electromagnetic theory, equations, all the stuff. Learning all these things, PCB design is the ultimate uh, application of your electrical engineering knowledge across the whole spectrum. Anyway, I'm getting excited. So, signal integrity. Why is this so important? Let me look at my notes. The electromagnetic theory. So you need to pay attention in physics class. If you're a junior or a sophomore, pay attention to physics class. If you happen to see this, if you're lucky enough to see this video, pay attention because you need this information when you lay out, if you want to lay out multi-layer high speed. Okay? And it's not too complicated. If you get through differential equations, man, high speed will be easy for you. Signal integrity will be easy for you. But the secret to high speed design is signal integrity. Understand it. The secret to signal integrity is electromagnetics theory. Okay? There are books I can recommend. Bogatin's book, High Speed Signal, High Speed Design Simplified. Um, Anything that's at high speed, look up those books, read them. Okay. A lot of people aren't talking about high speed design. Check out Nine Dots Connects. They do a really good job of explaining high speed design theory. But even beyond that, you need to read the books. Trust me, you need to read the books. This is where the rules of thumb come from. Why do I need a ground plane? What do I need a ground plane for? Oh, it's a rule of thumb. Use a ground plane. Okay, when do I use a 4-layer stack up? Questions like that. How thick do my traces need to be? How wide? Those questions are answered by understanding signal integrity. See, they don't tell you that. They give you these rules of thumb and put them together and hope you get lucky. Oh, you're welcome. You're welcome, Deborah. Putti or Petty, I think that is. Hopefully I didn't pronounce that wrong. I tried, but I said Deborah. You're welcome. Um, and I thank you all for watching. I really appreciate it. This means a lot to me that you would take your time to listen to what I have to say, my recommendations, my opinions. These are not law. These are just how I would recommend from training a couple hundred undergraduate students from zero to designing their own PCBs in 3 months, along with help, of course, because I was no expert, but I learned some things the hard way. Okay, the hard way. So I appreciate you being here. Right, signal and power integrity. So you need to pay attention. Go back to that EMAG theory. Okay, but you don't have to do all that. Just understand Maxwell equations, the Fleming's rule, the right hand rule, and read some books that I recommend. Right, and high speed. And lastly, PCB is the application. PCB design is the application of signal and power integrity. Now, power integrity, what's that about? Is very similar to signal integrity, but you need to be aware of how the currents flow. I've had a situation where at a job somewhere, I won't say which job, but where we were having EMI issues, right? And I've run into this too from my research. My signals were just noisy from my switch mode power supplies, and I couldn't figure out why. And the problem was that one of the problems for one of my boards was I had the power part of the circuit running straight across the digital part of the circuit. So you know when they say, "Oh, separate digital from analog," right? Analog is very, very sensitive to noise. The digital circuit, depending on how fast those switches uh, activate or those signals go up and down, which you would know if you designed the circuit. So that's point number two. I highly recommend knowing how to design the circuits because you'll know the details of the rise times and stuff. Those create issues down the road. In order to handle those issues, you need to know that they exist. In order to solve those issues, you need to know mastery of signal integrity. Signal integrity is the holy grail. I will say this right now. If you know nothing else, if you know how to design a PCB, but you want to get to high speed and multi-layer, learn signal integrity. That's gonna take you from being a 65,000 a year PCB designer to 130,000 per year PCB designer. I know because I've seen the numbers from Facebook, from NASA. They're looking for people who know how to practically do signal integrity simulation. Okay, I belabored that too much. Probably it's very important. That's the key. Multi-layer, high speed, signal integrity, and power integrity, and how to simulate that. Now, the final step, the road to professional hardware design engineering, ECAD software. You need to know the right tools. Okay. Now, we don't all have access to the right tools that we need, but the profession you need access, you need to learn some professional software tools. Now, here's what I recommend. Wait until you're ready to buy. Okay, how do I say? The first 6 steps before we get to ECAD. ECAD is the 7th step. Let me recap the last 6 steps. Number 1, how is the PCB fabricated? Number 2, learn how to design your own circuits and your schematics. Why? It's not mandatory. People make careers just doing PCB layout. People make careers just doing design. But man, if you know how to design your own circuit and how to lay it out, you'll be dangerous. You'll just you know the currents, you'll know the rise times for your components. You'll know which components are going to cause EMI issues, so you know how to handle the PCB layout. Third, footprints, IPC. Fourth, learn PCB layout process. Again, IPC-2221. Step 5, design for manufacturing. Doesn't matter if the circuit works in theory, it needs to be fabricatable. That's not a word, but it needs to be possible for it to be made. 6, signal and power integrity. This is the holy grail if you want to do multi-layer high-speed design. Signal and power integrity. That's the EMAG theory stuff. Okay. Lastly, ECAD software. If you want to be a professional, I'll just say it. You need to learn Altium or OrCAD. That's Cadence OrCAD or Allegro. Allegro is the big brother to OrCAD. If you don't have access to Allegro, that's fine. Once you learn OrCAD, you're good. Whether you learn 16.6, a lot of people have 16.6 still. I don't know, wherever you got it from. Hey, do you think 17.2? If you have access to 17.2, it's fine. You don't need to have 17.4, but it makes a certain part of the process easy for schematic design, for schematic completion. But anyway, you need to learn Cadence OrCAD or Altium. Why do I say that? Because if you want the maximum amount of job opportunities, learn those 2 software programs. And personally, I would recommend OrCAD or Allegro first. If you have an opportunity at your university to learn OrCAD or Allegro, do it. It's not as intuitive as Altium. That's true. I was learning Allegro from version 9 back in 2007 or 2006. 2006. Version 9, version 10, version 16.5, 16.6 for 3 years, then 17.2 for a couple of years, now 17.4. I have extensive experience in all of those versions. So if you have questions for me, and if you see a course that I made, don't worry about the course being at 17.2 or 17.4. You could ask me directly. I am a veteran. Well, okay, I'm not a veteran, but I got some experience 16.6. You might have come across my free PDF for 16.6. But anyway, let me get off my high horse. Let me get off my horse. I mean, it's not that high. It's a donkey, something like that. Anyway, so ECAD software, learn cadence, 67%, 70%. I mean, I don't know the actual numbers. From what I see, do the research yourself. If you know cadence software, you have the majority of the jobs fall in your lap. Okay. But you want to build all these skills prior to that or at the same time, right? Once you learn that cadence software, man, the sky is the limit. If you know how to do a multi-layer high-speed PCB design in cadence, man, you make that's 150 grand easy if you're gonna be in California. Uh, I'll tell you personally, because I had some level of proficiency with designing my own PCBs, in under in a year and a half, I went from making less than $28,000 a year as a teaching assistant to making over six figures. Okay. Yeah. And I see the reports on book titles or PDF links for all the points I've talked about. Absolutely. Um, Absolutely. So I will be doing that, and then we can go through that. I might make another video or do up a PDF. I'll probably do a PDF and then make another video to explain why. But I will make it rocky for sure. Um, yeah, learn Allegro. If you don't have access to Allegro, that's fine. Get access somehow. Okay, learn it on your job. Learn it at work. If you get access to the 15-day trial with Altium, try that. There is a free trial with OrCAD 17.4 on EMA's and Cadence's website. I don't recommend using the free trial until you're ready to do an actual multi-layer, that 6-layer or more, high-speed PCB design so that you can take advantage of all the professional features of that PCB SI. SI stands for signal integrity. I know that might be unfortunate to hear if you already downloaded the trial, but it only lasts for 30 days and on one machine. Doesn't matter how many emails you use. So it's unfortunate. We'll talk to Cadence or something to loosen that up. But I hear that there may be, anyway, I won't say anything about that. Just hold tight. If you can learn to apply the theory in Altium, you get that 15-day trial with Altium, then do that. And you could use, from as far as I remember, you can use a different email each time you want to get your Altium trial. And also, you can spend just $99 if you're a student, university with the edu address. You can spend $99 to get Altium for a year. That's what I do. I get the full professional Altium. I'm on 20.1 right now, and I use it to learn Altium and just apply the stuff so I could put it on my resume. And now I got another freelance opportunity. I've gotten well not okay. I have gotten a freelance opportunity just because I knew Altium, but I already had the basic skills in this list that I was telling you about, the PCB design skills, on top of the Allegro or Cadence. So I have that's about 100% of the professional market right there. But Cadence, learn that software. I'm telling you. Now, let's say you don't have access to either of them. You used up your licenses. You don't know how to get access. That's fine. You can start off with KiCad. It gives you access to 32 layers, maybe 64 layers. I can't remember. And then you could do a 6-layer high-speed board or whatever. You may not have the signal integrity simulation capabilities, which is critical, by the way, to be able to simulate signal integrity. Okay, great, Deborah. Deborah saying you can ask Altium for a license extension and they can do it for you. And Altium is very nicely vertically integrated. So Altium has that signal integrity simulation, and it's a nice, clean software. If you want access to the majority of the market, though, learn that Allegro. And really long term, if you really want big scale designs like across systems and consumer electronics, there's no escaping Cadence Allegro. It's the elephant in the room. But you can get real far with Altium. Learn both. That's what I say. Learn both. Okay. If you don't have access, or you don't really want to spend time, you don't want to use those trials yet, you can learn KiCad to get started. Free, completely free. Backed by NASA. Um, DigiKey, integration. Free. Use it. It's free. Okay? And it's fine. You're not you could use that as your training wheels until you become a professional. You lay out your multi-layer PCB, get it ordered, see if it works, right? Um Another popular one is Eagle. Eagle CAD is has become super popular, especially for hobbyists because of the price points. The price points are easier to work with. It's from Autodesk, so check that out as well. And it's integrated in Fusion 360. Now, I didn't mention mechanical CAD. All right, it's not mandatory to do PCB design, but I recommend it. I do mechanical CAD in Autodesk Inventor, and now I'm learning SolidWorks. Okay. Anyway, so I would say follow those 7 steps. It's pretty much a repeat of what's in the free PDF, but these resources I'm mentioning, um, this is this. I didn't say that that's the roadmap to get to professional Harvard. I just said those are 7 secrets. To be fair, to be fair, this is to get to the starter professional level so that you can start to really compete because things are becoming high speed. This is so you can compete and earn an income that you're happy with. This is to get your foot in the door. Once your foot in the door, you're going to do the rest of your learning on the job. Once your foot's in the door, you're going to do the rest of learning. But it's not the same before as where you to get up to speed, you need to get your foot in the door. No, no, you get up to speed using this order to make your life easier. So instead of taking a full year to get good and do your multi-layer high-speed design, you could do 3 months. Heck, if you spend 40 hours a week, I'll bet you money you do it in 1 to 2 weeks, right? Okay. So Aditya is asking, please add your views on SPICE modeling, IDO, DC-DC converters, data converters, suggestions, and its job scope at the end. Oh, right, right. Okay. Um, okay. Here's the truth about SPICE modeling. SPICE modeling saved my designs for switchable power supplies. Personally, I'm not gonna build a switchable power supply unless I simulate something about it first. That's my personal view. On one occasion, this has only happened on one occasion, I found that the PSpice model for a device in my circuit schematic had the correct input voltage limit. Now I'm going off script here because I'm answering Odysseus Pie's question. I already listed the 7 points. Okay. So if you want a recap of that, I'll put the 7 points on here. You can download the free PDF. The link will be in the description below. And I'm going to produce another PDF where I'll go through them again if you want in another video, maybe tonight or tomorrow, but we'll see. Um, but to answer Aditya's question, Spice simulation is not completely mandatory to do a schematic or PCB layout because a lot of times we don't have that. We don't have the IBIS models for everything. We don't have the Spice models for our components. But if at all possible, simulate the circuit. If at all possible, simulate the circuit in the schematic phase. By simulating a circuit in schematic phase, this was a chip from a certain manufacturer. I was about to say their name, but I won't say it because they're really good. They're very good. The chip simulation didn't match what I was supposed to get from the data sheet. I was like, what's going on? Like, I suppose the 8 volts is supposed to be the minimum. I mean, it's supposed to be the maximum or whatever input voltage for operation. It wasn't working, the simulation. I called the manufacturer. I said, what's going on here? The data sheet says this. The SPICE model says this. Is the SPICE model wrong? They said, actually, no, the SPICE model is correct. That's just an errata that we didn't include in this particular document. That only happened once. All the rest of the documentation is fantastic. But little things like that you can catch. But even more so, you can assess the switching power losses. So without having to do all the equations like so, So whenever you go to a research conference and then some guy, some professor or some smart guy who's like, "Oh, what are the switching power losses for your thing?" Like, I mean, who cares about switching power losses? Even though those are most important in switching mode power supply. Mm, Which because that limits the maximum frequency you can go to um, depending on the heat dissipation. Anyway, switching losses are pretty important. And so you can grab that important information so you don't get embarrassed at a research conference um, by doing a simulation, right? If you have a chip that can't be simulated, ditch that chip. Find another chip that's similar that has a spice model. I mean, that's what I do. I'm not trying to make my life harder. Designing switch mode power supplies is already difficult. Get a spice model to simulate it. Know that your theory works. Why wouldn't you do that? If at all possible. Please add your views, spice modeling, IDO, LDO, DC. Absolutely. I personally, I think there's no reason to not simulate a switch mode power supply when you're in the design phase. There should be no reason. If you have the wrong chip that can't be simulated, find a chip that can be simulated. Change your design. Texas Instruments is really good with having chips and passive. I say chips because you can always find you don't even need simulation. You don't even need spice models for passive components. So the chips are the important ones. Texas Instruments, check them out. Suggestions and his job scope at the end. The suggestion. Oh, so those were the suggestions. Texas Instruments, and then lastly, scope at the end. It helps save your butt before you get to layout. If you fix all the problems in the schematic phase and the design phase first, your layout's going to be much easier. You don't want to go to layout if you have a fundamental problem in your design. It doesn't make any sense. And here's another thing. When you could see the actual currents and peaks, the actual that based on the spice model, and they might differ a little from what's in the data sheet for certain chips and stuff. When you see the actual peak current going through the inductor, and you chose an inductor whose peak saturation is 7 ampere. No, this whose peak saturation is 3.5 ampere, and your circuit, your current going through that inductor line is actually 7 ampere or 5 ampere even, and then your circuit gets choked up and starts when you build a circuit and you didn't notice that, and then as soon as you start applying the voltage and it starts switching with your digital control, um, your it starts ramping up and immediately drops off, and you never get the output voltage you want, and your circuit is noisy, and you could hear the audible noise. Your inductor got saturated. You would know that if you knew the design. You would know that if you didn't do the design, but you simulated it and you missed that the peak is supposed to go through there. You would know that if even if you and then you would to choose the right inductor. Even if you chose the right inductor, you could run into problems in the PCB layout if your trace width isn't wide enough for the copper thickness. This is why I believe design is so important, and this is why simulation is important. Uh, and absolutely, signal integrity. Now, here's the thing: you don't need spice models to do signal integrity simulations because that's a whole other thing. But I strongly recommend, and in fact, it's not even a recommendation at this point. It's mandatory in the job descriptions. If you're doing multi-layer PCBs, I mean, or single, double layer, doesn't matter. If you're doing signal integrity and high speed, the company is going to want you to know, like a good company who's serious about their stuff, they're going to want you to know how to do signal integrity simulations and power integrity simulations. So software like ANSYS, um, Altium Designer, definitely signal integrity or Sigrity from and Sig Explorer from Cadence, which are embedded in the OrCAD professional trial, 30-day trial that you can only use once. So just be careful. KiCad, I don't know if that has that feature, even though you could do like 32 layers or more. Maybe 32 layers max. I don't know if that has an Eagle. I think it has EagleCAD. I think it has some signal to integrity simulation. I haven't done it myself, so I don't know. But I think I've seen a company say that. Did you learn OrCAD all by yourself, or did you have a mentor or formal training? I learned OrCAD the hard way all by myself and by reading the documentation. That's for the first 6 years across all the different versions. Now, to be fair, OrCAD 9.1, our professor, I had a professor in Circuits 1 who showed us how to do the circuit simulation. But after I left, and that was for Circuits 1 and Circuits 2. But beside that, just some nodal analysis stuff. Besides that, um, after the summer went, I didn't remember any of that stuff. So I was starting from zero when I transferred to my university. And then I had to learn the hard way. And I got showed tips and tricks here and there by my teaching assistants in the labs, but those were few and far in between. I had to read the documentation and go online and look at forums that explain different things. I mean, it was just, I literally um, was picking at my hair sometimes at midnight with how stressed I was to learn OrCAD back in the 10.1 days or 10.2 and the 16.5 days. Um, but the documentation helped me. Um, but that's only because I knew after a while, and and uh, I got advice from some of my peers on how to do some of the simulations from documents that they happen to have that happen to explain the procedure. So I got advice. I didn't straight copy. I did what I could, and we'd have inconsistent results and blah blah blah. But I read the documentation. After about 6 years, it was until 2018, no, 2000, what are we in? Oh, 2019, did I take my very first course in OrCAD from EMA Design Automation. So from 2007 to 2019, it was 98%, 95% learning by myself. That's a long answer to a simple question. But I just wanted you to see and understand how challenging it was. Do I have a mentor formal training? And also I learned from a certain book. I forgot to mention a book. This is a great book. Craig Mitzner's Complete PCB Design using OrCAD. I highly recommend that book. That's the that's the special book. Do you plan on having tutorials using Sigrity and what to look for? Oh, yes. I'm glad you asked that question. Um, I'm glad you asked that question. If you're at this point in the video or the stream, you want to rewind to catch the 7 points. It was around probably the 45-minute mark. Actually, I'll make timestamps for this. So yeah, do you plan on having tutorials using Sigrity? Yes, actually, that's people have been asking me that, and that's something I've been working with and using because I'm been working on my own high-speed PCBs because Internet of Things is becoming a thing. And I have a project that I'm working on for a startup. And I already forgot your question, even though I'm staring at it, Jeffrey. Do you plan on having tutorial? Okay, yes. And so actually I have a program that I was wanting to announce on the official webinar. But I don't have it set up. I don't have a payment link set up yet. But I guess I'll announce it. Do you want me to announce a program that I have that I plan to use do you want me to talk about that program? I'm already an hour into this video. Well, it's fine. Anybody could pause. But if you're curious about a program that I'm making that I'm releasing next week, actually Sunday night, I haven't made the videos. What I plan on doing, because it's actually probably kind of I've been made some courses already and videos already, but every time people have questions and they're like, okay, what about this and what about that? And I realize I need to make more videos to explain this stuff. So what I'm gonna do is actually make a start a course where I literally, like I'm doing now, answer questions in real time in groups and in one-on-one sessions, showing Sigrity and how to do this stuff, looking at the reflections, and why those are happening, and how to use the OrCAD software to fix these problems. So, like, see how you see in the promo videos from EMA Design Automation and Cadence? I'll show you the theory. We'll go through the theory first, and then how to apply that theory in the Sigrity tool to fix your problem. That is how you answer the question, will it work? So yes, the short answer is yes. The program is it's new since I haven't made it yet, since it'll be us doing the things live. But that's the best way to actually get questions answered and to actually do the accountability thing. So you don't feel like you're alone because you're literally not alone, and to actually uh, get to professional level, or at least getting your foot in the door into a company so you get paid. Okay. That's the program I'm starting, I guess Sunday night or Monday. If you'd like to learn more about that, just ask me. I don't have a payment link set up yet. It's, I don't know, uh since it's in its infancy and this would be the beta launch of it, or the alpha launch. It's people who get in on Sunday night or Monday will get like they will get it at a fourth of the price that I'm going to release it at. Like, so you literally get 75% off. Um yeah. And that's for good. And that's not even the bonuses. So to give you an idea of the program, I might as well talk about it now. Uh Here's the thing. Everybody comes in at different levels, but in order to capture all these things, I believe in the I believe in the power of repetition and understanding underlying principles. It may sound like a lot when I talk about it right now, but it's actually the most efficient way to do this. I know because I've literally taken four, no, I've literally taken 250 plus undergrads from knowing nothing about PCB layout to designing 6-layer and 8-layer PCBs. Of course, with mentorship and guidance from our veteran professor who had 20 years of experience when I didn't know nothing. So I learned from him, transfer that knowledge. I learned he was the master at the theory. I was the master at OrCAD and Allegro because we were using Allegro. I learned from him. I transmit that knowledge, combine it with Allegro, and tell it to the students. So you're in good hands. Um, and they make money. They're making more money than I am probably, which is sad because I went in power system. Anyway, whatever. The program would be project. We're gonna do 4 projects. Maybe it's a little crazy. The first project, 2-layer PCB, very popular board. The STM32 Blue Pill. Why? It's a better Arduino Nano, 100 megahertz chip, cheaper than the Atmega 32 chip. Just saying. That's to get you through the process, to understand the process of the whole thing, start to finish, schematic and everything, just to get you used to the PCB layout process. You actually, if you want, you can fabricate it, send it off, come back, it works. Second project, Arduino Uno, classic. Sensors and all that stuff, Internet of Things, popular board. That's so we can learn and focus on design for manufacturing. And that's where we talk about in the Arduino schematic, we do the multi-page schematic design. That's where you learn about off-page connectors, exporting and importing properties, the optimal way to find parts fast and to drop it into your schematic. A lot of efficiency hacks. Third project, the Beagle Bone Black 6-layer PCB. Here's the thing about PCB layer stack up, and I'm probably going to talk about it in another video in the training this weekend, maybe tomorrow. Once you learn how to do, once you learn the theory behind a 4-layer PCB and a 2-layer and a 6-layer PCB, you can do a 10-layer PCB because you know the theory. It's not magic. If you know differential equations, you could do, you learn PCB design. So that's where we do the 6-layer PCB. Also, here's the thing. It's a guy. These are all, why am I using boards that are already made? Why not do custom boards just from scratch? I want to make sure it works. You don't want to design a PCB and you're learning um, and then it's like, well, hopefully this works. No, you want to learn the theory, how they did it, do it yourself, and then, if you're unsure about something, we explain the theory. I explain why they did it this way, how it could actually be improved, because there are some improvements that could be made to these boards, and then still use that as a reference to say, send it to the manufacturer, you'll get it back. We know it works. They've already tested it. So that's the BeagleBone Black. I'm looking crazy on the video here. Jeez. All right. And then the fourth project is going to be a buck boost, a maximum power point tracking, switching power converter. That one, right. The third project, BeagleBone Black, that's where we do the SIGRD simulation stuff, and that's what we'll be focused on. We'll probably start with layout and then do schematic on the back end. That's where we get into hierarchical schematic, bill of materials, management. And here's the thing. We're talking about, I'm not going to do the cookie cutter. Here's step 1, step 2. If everything goes fine, then that's great. How I'm going to be throwing issues at you, issues that we have at my job. I've had at my job, issues where I work with clients, and they borrowed somebody's design from an old engineer or whatever who already left the company, and how to fix those problems, how to swap out parts and stuff. So this isn't going to be okay, A, B, C, D, everything's perfect in the world, and it works. That'll be the first design, maybe the second. But no, I'm going to be throwing problems at you, curveballs. Okay. And then SIGRD stuff. And then we get the BeagleBone Black made, our own custom BeagleBone Black. I mean, it's essentially the same thing. If you want it made, that's an additional option or whatever, but we'll talk about it. The fourth is a switch mode power supply buck boost converter for maximum power point tracking. That whole thing we're going to simulate in PSpice, and we're also going to simulate the availability of parts. What are the choke points, Monte Carlo analysis and stuff like that. That's where we really get into the PSpice for power electronics. And then we lay out the PCB, and that's where we focus more on power delivery network. I forgot to mention that the power integrity, power delivery network, and of course some signal integrity, because they're interlinked. There are 4 bonuses in addition to that, but that's the core program. That core program, if anybody's curious about the price of that core program with those 4 projects where I run everyone through the gauntlet over the course of a month or 2, maybe it'll be 3 months, I don't know, but I'm trying to get it in a month and a half, 6 weeks. Let me know if you're curious about like the pricing of that. If you get in then you get the deepest discount. That'll be the lowest you'll ever get it, since it's the test run. I mean, not for me, since I've done this, I can't count how many times with people who know zero about PCB design. So yeah, would anyone like to know the price, or do you want to message me or get on a call to find out? Okay, I probably lost everybody, but that's okay, I guess. No, it's pretty bad. All right, so that is the program that'll be coming out. If you're curious about it, just feel free to message me, or if you want to hear about it, just put it in the chat. Is this course for beginners? This course is actually designed, optimized for beginners. Okay, cool. This is optimized and designed for beginners. So the same thing. This is what I would do if I started off with 0 in PCB design, which is what happened to me as a graduate. As I was a graduate student, didn't know nothing about PCB design. This is the course I'd make if I could do it all over again, knowing nothing. Nothing. In fact, this is optimal for the beginners. The seasoned professionals, I need a different program for them actually, because they come in at different areas and they want to do maintenance stuff, and that's too much extra stuff for beginners. So okay, Deborah says she's curious. So this program starts at 497. I was actually gonna put it at 997, but you guys are I wasn't even actually gonna talk about it. But this program's gonna start at 497. And now that I'm talking about it, not only do I take you through the four projects, but you get some bonuses. And okay. So the bonuses would be the whole point is to become a professional six-figure PCB designer. I'm not trying to do no five figures. I'm trying to do six figures a year. Okay. And when I say I'm trying, I mean I'm trying to I want by the time you're done with this, we're gonna be targeting jobs or roles in six figures. Doesn't matter if you have a job right now. Once you finish these up, put these on your portfolio, you could start at any time hunting for six figure. I mean, you may have a six figure job, but but what if it's a job you don't like as much as PCB design? What if you get paid six figures to do PCB design and you really like it? So good deal, right? If you don't have a job, it's fine. Um, then we will make sure you get that. So the first bonus is here's the situation with the first bonus. Why I think this is so important, especially for beginners. I was an international student. I'm from the Bahamas. I was born and raised in the Bahamas. I did college for 3 years at the College of the Bahamas. Then I transferred, starting with engineering physics. Then I went to electrical engineering because I thought, well, nobody's going to pay for my physics degree. I can't get a real job with that. So I transferred to the University of Arkansas because they had scholarships and I had no money. So even though it took me a lot of years, I with no income, if I didn't keep my grades up, I literally couldn't stay in the country as an international student. Getting jobs was the hardest thing. I'm an introvert. I don't make. I have like one or two friends at most that are really close to me. I I had no network like that, so I had no prospects, and I just didn't get or understand internships and the game and the system and the resumes, and I already knew I wanted to do graduate school. So I got stuck in a situation where I was a graduate student 4 years in, no internship. That's pretty bad. Okay, so don't be me. If anybody's watching as a student, don't be me. Get internships if you can. Take advantage of that. But let's say you are in a situation, because I know colleagues of mine, international students, we'd had no real internships or no real jobs, no industry experience. And I was submitting applications for 3 years. This is embarrassing. 3 years and got two interviews. And that was only in the third year. So you know something was wrong, right? I was doing everything wrong. Unfortunately, it's normal to be sending a bunch of applications and hear nothing back. It's called the black hole. But I did it for 3 years. You think I'd get something? I got discouraged. I got depressed. I stopped applying for jobs for a whole year and a half. Um, and so, you know, I thought, man, nobody wants me. Nobody wants my skill. I attached that to my value as a person, which was the wrong thing to do. But it's hard when you put in so much work and you get discouraged. Anyway, that was up until 2018. I was working as a TA, getting no serious callbacks for actual jobs. And then the few interviews I did poorly at. And then the two interviews I actually did well at, they wouldn't hire me because it was US residents only. So anyway, finally, eventually got residency, got my green card, um, and I still couldn't get any job like resume like opportunities. So I happened to go to a career fair, talk to someone, one of my students who was already in the engineering field 2 years before I was, even though I was his TA. Talk to him, talk to someone. I'm telling a whole story here. I'm sorry, maybe you don't want to hear all this. Um, and the so the training is already over for today. If you want to jump off, you could jump off. But I'm just telling my story about this bonus. Why I'm making this bonus, especially for beginners. It's very defeating when you put out so many job applications and you hear back nothing. So the first bonus is how I went from hearing crickets, hearing nothing, to in a year and a half. No, not even that. I got my first internship just by a conversation and finally knowing the right things to say in the interview. I happened to fumble my way through that. Got my first internship. And I was applying to jobs, but not really hearing anything back. It wasn't until I did certain things online that recruiters started sort of reaching out to me. One call a week, and I didn't apply to a job. That was that was the holy grail for me at the time. I happened to land a job offer right on the last 2 days of my internship when I was going to go back to Arkansas. Um, so I was like, okay, I don't care where it is. I'm going to Texas. Got my job then. Um, but I still wasn't good at getting applications through and getting consistent recruiters. I did certain things online and into my resume that, man, if I had known the secrets, I would have been experienced like nobody's business by this is still as recent as 2018. I made those important changes. Big companies started reaching out to me. Symantec reached out to me just in 2019. I had to say no because I just took a job at SunPower, and I that's this is where my interest is right now. Other companies that I've been chasing for years, like Apple Computer, they reached out to me. I applied to 150 jobs at Apple, or maybe 125. Nothing back. It wasn't until I changed some things back about a year and a half ago, Apple reached out. I did an interview. Unfortunately, I didn't know enough about a certain type of circuit they wanted for their switch mode power supplies. So, that's fine. However, I still have a relationship with their recruiter. He said, hey, Kirsch, if you ever see a job that you really want and that you know you're ready for, let me know. We can get you an interview for it. He just reached out to me last month. Um, so there's that. Big company. Who else? Google reached out to me. I haven't interviewed with them because I don't want to bomb their interview. I'm traumatized from the Apple interview that I failed. Okay. um, if I had known what I'm going to teach you in this course, I would have gotten the job at Apple. Okay. Um, Let me see. Anyway, where I am now, I have to keep people away from emailing me. I have my LinkedIn profile set to not. I'm not looking for jobs. People keep emailing me every week. They're telling me, Kirsch, give me your resume. Give me your resume. I'm like, no, I have a job. Like, I don't say leave me alone. I say, I'm trying to do my thing with this company right now. They still email me. So if you want to go from hearing crickets to every day you check your inbox, people have somehow got your personal email address to they trying to pull you to interview with them. That's bonus number one. I'll show you the system to get the job you want. It's a system. I had to learn it the hard way, and that's the longest explanation, but that's the bonus number one. Bonus number two: cheat sheets and guides to speed up your PCB design process. We're talking optimization, footprint, automatic name creation and generation, extra tools you can use. PCB Library Expert Pro Lite, check it out. Um, and even if you don't have that software, how to generate your own Excel spreadsheet to help automate some things in your PCB design process, and cheat sheets and guides and PDFs for techniques to memorize the steps in OrCAD and Allegro. Okay, the special memory techniques. I've been doing some JEDI stuff to memorize it. Just I mean, just like, I mean, it's not just like that, but man, you'd be amazed. Okay, and you can apply that technique to any other CAD software. In fact, any other engineering software. But I won't talk about that. That's the memory master technique. Third bonus: mechanical enclosures and designs, and how to set yourself up to be a freelance. So I do freelance PCB design for special clients, startup companies, US startup companies. I don't really go on the Fiverr and Upwork and stuff. You could do that. I don't do the massive marketplace thing. I communicate with people and present my skill set and stuff, and then I get jobs that way, side gigs. So that's how I'm able to um, fund myself, multiple streams of income that work well for me. In any disaster, right? And then uh, there's a fourth bonus, but I think I'm gonna leave that. Okay, in the second bonus, I'm gonna include. I probably no. In the first bonus, I'll probably include projects that companies actually want. Projects that you can do to get you into the companies you want and job descriptions you want. It's a very simple process. Takes time and work, but I'll show you how to do that. So that's the whole program, and that's all for 497 for you guys. Okay. If you want to enroll, you have today, and actually, I was going to announce this Sunday night, and maybe Monday, and then it would disappear. That opportunity would disappear. So 497 US dollars. Okay, to get the four projects, the four bonuses. Okay, and this would be a live class that runs for about 6 weeks or more, maybe 10 weeks, just to make it easier. But we'll see. And you would be building it with me. That's why it's so. That's why it's on the low end. So, just the high-speed PCB design course with downloadable videos, just that project alone with Sigrity, that would be the holy grail of what you would need to really set yourself up. Just that alone is worth $497. So I'm giving you all this extra stuff because I want you to be successful. Okay. Um, all right. So if you're curious about that, you can talk to me. I don't have a payment link. I mean, if you want, you can send me. You can send the payment to kirsch.mackey@gmail.com for my PayPal. You can PayPal kirsch.mackey@gmail.com. I'll type it in so it doesn't accidentally go to the wrong person. You know, and then we do it that way. And then even if you're like, well, Kirsch, $497. I mean, come on, what are you doing? It's a pandemic. We don't have money. You gotta be careful about saving that stuff. That's fine. We can do a payment plan. You know, 3 payments of something like 197 or something like that, and that's one payment a month or something like that. Because I understand the situation. That's why I'm going as low as the 497. Because the the bonuses alone, like the whole coaching and everything for the real time, I like work with you. I'm not talking about I make some videos, you watch them, good luck. No, I'm talking about it's you and me, we talk, you show me your resume. I've been doing this stuff and I say, fix this, change this. Which job do you want? This is what you need to do. This is how you need to set up your LinkedIn profile. This is how you get people coming to you. This is the projects you need to do for this company. And also you get access to my network of engineers who I know, and I could give my personal recommendation because we went through the training together. Okay. And here's the thing, you don't have to finish the program to get a job or to switch jobs or to start your freelance business stuff. In fact, I don't even recommend waiting till you finish the program. Start. Is this a one-on-one or small group course? This is a small group course, and um, for this is a small group course where I go through it every week. I think maybe one or two sessions a week. I haven't figured that part out. Then for each person, I'll do the one-on-one for 30 minutes a week, face to face. Now, when I say 30 minutes, I'm really bad with time. As you can see, this I said this is supposed to be 35 minutes, but it's actually an hour and a half. I'm bad with time, so more than likely I'm going to spend an hour with each of you each week or every other week at minimum. So there's going to be the group and one-on-one. I was actually not even gonna do the one-on-one because that's like a $2,000. That's supposed to be a $2,000 program, which this is going to become a $2,000 program soon, like in a month. Um, After we test things out, work through all the kinks and optimize. But see, since the program isn't made, I'm not gonna charge no 2 grand. We're gonna go through it one-on-one and do all the stuff. Anyway, that's a really long answer to a question. Yes, it'll be small group and one-on-one. We'll have question and answer session once a week. We'll have the group coaching um, once a week, and then we'll do the one-on-ones with each of you. I'm good. Each of you, me and you, not no other people. Me and you, your situation, because every person is unique. Um, and we'll schedule that, and then there's another thing I'm supposed to be doing. Oh, right. Once the group coaching is actually done, I upload the videos to the online learning platform, hasofu.com. It's under construction. It'll be ready. It'll be fixed this weekend. No, not fixed. I'm literally building it, but it's almost ready. And that's where I release the recordings of the videos. And people are going to have questions. I upload videos to answer those questions. Um, and there's a third thing. Oh, right. You get to email me. So you probably already know I answer emails already, right? For free, which I probably shouldn't be doing, but people need help. Life is hard. Things are challenging. I got help when I needed it when I didn't know anything. So um, you can send as many emails as you want in the program. We don't even have to meet face to face. We could save the face to face for you know the once a week face to face with just me and you for a later time, or you could save your questions for the group thing. That'll slow down the group thing, but you can always email me, right? And I'll answer as quickly as I can. And here's the thing, my answer is probably going to be in the form of a video that I upload into the knowledge base, the knowledge portal that everybody else can access as well. So yeah, there's that. You'll have the knowledge portal. I forgot about that bonus. Random off the wall questions about how do I do this? What about this? You didn't cover this. There was no time. It was like, here we go. And keep in mind, I have access to like EMA, like, and also a lot of training manual and content. So that's all I'm going to say about that. Okay, I'm not going to share those because those can't be distributed. What I'm saying is it's easy enough to look through the training material from EMA and from Cadence and then just make a video to answer your question. Like, so wow. So that was a question from Jeffrey Liu. Jeffrey would be okay. You'd be interested. Is this course for beginners? Yes, for complete beginners. $497. Um, yeah. Enrollment for this will close at this price point. Will close. Did I say Tuesday? I wonder if I should keep it open. Anyway, I haven't decided. And does anyone have any more questions? Feel free to ask me questions. But I will be coming off soon. Let me check something real quick. One second. Okay, cool. All right. So I guess nobody else has any more questions. I'll create a timestamp comment or in the description so that you can navigate I guess the roadmap or blueprint. Here's the other thing. You don't like people are learning PCB design and getting jobs. on their own, right? So why would I say this? I guess I'm shooting myself in the foot. But I mean, you guys are smart. You're engineers. You know this. You can follow those steps and get the content and the material and the PDFs and all that stuff, and um, have your own plan and execute on those things, and do this stuff yourself, right? You can get to the high PCB, the high speed stuff. This isn't new knowledge, new novel stuff, right? I'm just doing what I can to use techniques that I've learned over time, that work with people to help you accelerate that process so it doesn't take a year, which still isn't bad actually. Um, if you like to take your time with it, that's fine. Once you get enrolled, if the 6 weeks is up and we finish the training, you will always have access to the bonuses. You get for the bonuses, you may only have access to the bonuses if you enroll before I close this offer. Um, I have to figure out how to set that up, like past the job thing. But if you enroll now, you get the main course, all the bonuses, the live stuff. When we finish all the stuff, you don't even have to start immediately if you don't want to. You could watch the recordings, the question and answer stuff, and start next year, start 6 months from now. And by then, keep in mind, the program is only going to improve. I'm always going to be improving it. So you're getting access, you're getting just permanent access to all the stuff and future developments of the course and the program, right? So, you know, um, trying to think. Yeah, so PayPal me, and kirsch.mackey@gmail.com is my email where you can PayPal me. If you don't have access to PayPal, we can figure something out. Just email me directly. Maybe you want, if just email me at kirsch@hasofu.com. Maybe you don't want your business out there. Maybe you don't want people knowing that you want to enroll. That's fine. Just email me. We'll keep it private, confidential. Everything's confidential and private. If you don't want to go through the order of steps in the program, that's fine. I literally do unconventional stuff all the time in Allegro. Weird stuff. You'd be surprised at what other things you can do with Allegro and OrCAD. Okay. Um, yeah. Yeah. And just as a thought, I wonder if I should release the same course using the different CAD software, because I know Altium and I'm going to know EagleCAD soon, and KiCad too. Anyway, those are just me thinking out loud. I hope you had a great time watching this video. Um, Thank you for coming to my live presentation, and that's the end. If you have any questions, email me at kirsch@hasofu.com. Please don't forget. Oh, comment on the description, comment below if you have any more questions. I'll look through the comments specifically for this, especially. You have a great day. I don't see any more questions, so I'm going to dip. And until we meet again or something, just happy engineering. Keep doing your thing. All right. Bye, everybody.